Hello, welcome to KAJOS Consultants. My name is Joshua. Today, we are going to look at the evidence of multicollinearity when we run a regression analysis. So multicollinearity occurs when there is a correlation between the independent variables. So one of the things that we really need to focus on is what are some of the problems that comes when there's an evidence of multicollinearity in linear regression analysis. So the problem number one that we are likely to experience is we'll have difficulty in choosing the list of significant variables for the model, in that if the model gives you different results every time. So that is one of the problems. The second, the coefficient of estimates will be unstable, and this will be really hard to interpret the model. So in simple words, it will be difficult to tell the scale of changes to the output if one of the predicted factors changes by 1 unit, as when you are interpreting the coefficient table. And second, they will be also, due to the unstable models that we'll have, they will find some of the value will be overfitting. And if you apply the such model to another sample of data, then the accuracy will drop significantly. But then how can we rectify this problem? Once you have run such analysis and you find there's an evidence of multicollinearity, then you will identify those variables which have the values more than 10, and we are going to look at in our next set of discussion under the SPSS data. So with me here, the SPSS data that I'm going to use for this particular analysis, and I will choose the dependent variable cells and the independent variable as the number of stores that we'll have for this particular analysis. So how do we go about it? Simply place your cursor on the SPSS main menu under the Analyze main menu, then go to Regression, then Linear. So under Linear, then we can look for where the cells are. So we have the cells, and this extremely move to the dependent variable. Then we'll look for the stores. And we have them here from, so these are the values you're going to use as the independent variable. Then we'll move them under the independent dialog box. So we'll choose statistics we want to run. So we are interested in the collinearity diagnostics. Yeah, that is where our interest lies. Can just check on these plots. The Z predictor will be on the X, then the Z residual will be on the Y axis. So we will not really need to check the histogram and the normal probability plots, since these ones are normally used to check the normality when you are doing the linear regression. So under Save, we can mark the unstandardized, then Continue. Yeah, options, can leave it the way it is, then we exclude cases listwise. Then click on Continue to activate the output dialog box. So we can then check. We'll find a number of tables here, generated variables entered, and remove the model summary table, which normally tell us how much the independent variable explain the dependent variable, and simply by focusing on the R square value. So we see the model will explain 26%. Then we also have the ANOVA value, which is significant. But now when we want to check on the evidence of collinearity, then we have to pick the two tables. And that table is the coefficients table that we have here, and the collinearity diagnostics table. So first, let me just pick all of them. So if we right click, can just cut, then we paste them here. So we can then paste have all those tables there. Then you can out of it window so that we have all the values visible as they're supposed to be. So our first focus will be the coefficients table, and we'll mostly focus on the variance inflation factors column. So how do we know whether there's an evidence of multicollinearity using the variance inflation factor column? So if the variance inflation factors values are more than 10, then we'll say that there's an evidence of multicollinearity, and in that case, this will not be really fit to run the regression or the linear regression analysis. But if just some of the variables have the variance inflation factor, and that is specifically on the independent variable, some of them have a variance inflation factors above 10, then if you want to have an effective analysis of the linear regression, then we can remove such variables and remain with the variables that does not have that are not multicollinear to this model. So as you can see here, all our variance inflation factors, they are all below 10. So in this case, there is no evidence of multicollinearity, and this analysis for regression, linear regression is acceptable. Can also come and do some small assessment on the collinearity diagnostics table. The collinearity diagnostics table, out of it, that's also to window. And this one will check on the condition index. If you have the condition index values less than 50, then that one also shows there's no evidence of multicollinearity, and with the same can be ascertained or evidenced by the variance proportion value, and you will continuously check on all the independent variables where we have and their variance proportion values. If you get the variance proportion values that are above 0.8, then we can say that there's an evidence of multicollinearity, and that particular data will not be fit for linear regression analysis. But just see the same way we did on the coefficients table, if you check, you find one of them having a variance inflation or the condition index value under the condition here, under the condition index section, and we find there's some values that are more than 50, then we can simply remove such independent values and retain those whose variance inflation factor is below than 10, and those whose condition index values are less than 50, and with the variance proportions of less than 0.08. So just to interpret the such data, so this is how we do the determining multicollinearity and the interpretation that we have attached to it, as I explained above. So the data we subject is first to the assumption of regression analysis, and we found that there was no major violation reported. All our variance inflation factors were below 10. They were all below 10. Then the condition index, which now points to the exact values of such analysis. And the condition points the exact causes, and it was evident that the dimension of below 50, with each having a variance proportion below 0.8, as I also explained above. So in that case, then the assumption showed no evidence of multicollinearity. The relationship between the independent variable was not strong. Thus, this data is then acceptable for carrying out a linear regression. Thank you very much for watching this tutorial, and kindly hit on the subscription tab below to subscribe for more of these updates.